Hang on a sec, everybody. Um, sec, everybody. Hello. Sorry, give me a sec. I am just double checking that everything is working. Yes, cool, fantastic. Okay, we're in. We're in. We're in. Hi, everybody. Let me hide that. Let me do this. Let me do that. I'm just getting my stuff in order. Hello, right, I'm in. Sorry. Okay. Hi, everybody. I've been rushing around. I lost a cable. Guys, I lost the cable for my camera, and you guys don't need to know this, but I found it. Okay, but it was quite a stressful few minutes before we started. Right, who we got in the chats? Give me a little hello. Will's in first this week. Hello, Will. You got a little chat in there at 10:59. Fantastic. Good for you for turning up 1 minute early. Jacob, good morning again. William, Sienna, I'm very good, thank you. Thank you for asking. Helena, hello, Helena, I'm very good, thank you. Thank you for asking. Hi, Ruby. Hi, Sophia. Hi, Martha. Ellie. Tom. Alice, Sabrina, Liz, Ruby, I'm good, thanks. Tom as well, and Karishma and Helena. Hello, 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 hello. Right, now, what are we going to do today? I'm sorry, guys, I'm a bit ill. I'm getting a bit ill in the throat, and I haven't brought a water. Oh my gosh. Should we do some maths? Yes. Okay. Who's here for the maths? Let me share my screen and show you guys what I'm going to be going through today. So I'm going to be doing, where is it? Yeah. I'm going to start because I know you're all here for the calculator hacks. I'm here. I'm going to start with a calculator hack. I actually didn't write this in. And then I'm going to do trial and error. Now, listen, I know that trial and error, I'm going to start with the calculator hack. I know that trial and error. No, wait, can everybody see this? Is this okay? Yes, yes, yes. Just let me know in the chats. Hi, Ariana. How you doing? This is all good. You guys can see me, hear me. Off we go. Nice. Thank you, Liz. Thank you, Sienna. Thank you, Tom. Okay. So trial and error doesn't sound like the coolest topic or like who's actually taught trial and error? Can you guys just let me know in the chats? Who's actually taught how to do trial and error at school? Are you told this by your teachers, or do they kind of go? So a bunch of people saying no, some people saying yes, some people saying sort of, mainly no. Okay, I will show you trial and error because essentially when you get to nasty questions, there's two ways to do it. You can either use algebra or trial and error. And I just know that loads of people hate algebra. And so I want to get you guys good at trial and error because it's a really good backup option in case you don't know how to do it with algebra. So I'm going to show you how to do that. And then I'm going to go into the Zoom room and see what you guys want to go through. So then I'll just do your questions after that. Okay, let's start with the calculator hack. Let's go. So, standard form. Who hates standard form? The most boring of all the topics out there. It's standard form. Who else hates it? What do you guys think? Do you guys like it? Not me, I'm so good, says Will. I actually don't mind it, says Sophia. Okay, I'm not going to spend ages on this. Standard form is basically a way of writing numbers, number times 10 to the power of something. And most of you guys might be like, why the hell? Why do we have to do this? The idea of standard form is like if you're talking about how far away galaxies are, if you're talking about big numbers or small numbers, it's just so pointless to say, oh, well, 7 billion, trillion, trillion, billion, trillion, trillion, billion. It's just, you'll be there for ages. And so you end up saying like 3 times 10 to the 85, which means very, very big. And likewise, if you're talking about the size of atoms, you don't want, there's all those words like millimeter, micrometer, nanometer. You don't want to come up with all these crazy words to be like pemto, mempto, fecometer, or trillionth of a billion, trillionth, trillionth. So the reason why you do these is if you're talking about very big or very small, it does make sense to describe things in like, oh, times 10 to the minus 40 is extremely small, or times 10 to the 75 is very big. Okay, so that's the reason that you do this. So I know it doesn't look exciting, but I'm sure like some of you might be interested at some point in your life at either things that are big or things that are small. Actually, maybe stick this in the chat. When I say big, I mean like astronomy, galaxies, like space travel. And when I say small, I mean like atoms, like chemistry, like splitting an atom, or anything small. Are you guys interested in big things or small things? I mean, is that a really mad question? Stick it in the chat, so I'm interested. Have you guys got any interest in this stuff? If you're interested in space, you're going to be looking at big things. If you're interested in chemistry and biology and looking at things in microscopes and tiny things, then you'll be interested in small things. I don't know. Not really, says Sabrina. That's fine. Okay. Then you don't need to worry about this. I'll just show you how to do it on your calculator and then we can all just go. Okay. If, look, and as I say, you're not going to get excited about standard form in a GCSE context. If you really are interested in these things, if you go on to study them later on, you will actually care about the thing that you're studying. But for the moment, I'm sure most people don't care about this. So let me just show you. Just use your calculator, guys. Just use your calculator to help you. This is a 4 mark question. Like, there's people that are like, maybe I should take. There's people that think I'm going to take foundation because higher is too difficult. Now, look, there's some horrible questions on the higher tier paper, but if you know how your calculator works, you just use it. Like, okay, write this as an ordinary number. Okay, just literally punch into your calculator 4.5 times 10 to the power of 5. You just need to know how the buttons work. Bang, there you go. There's a mark in your GCSE. I mean, you could teach a toddler how to do this. I'm not saying I'm not belittling anyone that finds this difficult, by the way. I'm not saying, but I'm just saying, like, just use your calculator. I've not done anything. I've typed that into my calculator. I get the answer. Just know that your calculator can do so many things for you. A lot of people are not teaching you this, guys, but I'm here to show you your calculator hacks. Here you go. This one. Now, this one's a little bit more difficult. Okay. You can't just punch this in. Oh, can you? You can. Oh, wow. Look, 7 times 10 to the minus 3. All I did was hit S to D there. I punched this in, I put equals, it gave it to me as a nasty fraction, and I went bang. And I've got another mark in my GCSE. Now, the pass mark on a GCSE paper is about 20%. This is about a tenth of the way to passing your GCSEs. Actually, this is out of 80. This is a GCSE. I think these are usually out of 80. Yeah, 80. That you're even more than a tenth of the way to passing your GCSEs. I haven't taught you anything. Oh, what about this question? Surely this one's horrible. This is punch it into your calculator. Why bother? I can teach you standard form if you want. Okay. And for those of you that are on the platform, I've got videos on it, so you guys can go and watch videos on standard form if you want to learn how to do it in a non-calculator paper or stuff like this. But why not just punch it in? There you go. 4730. Okay, now you've got 3 out of 4, and I've not taught you anything. Now, the final mark, yeah, you got to convert this to standard form, but you can still use your calculator to check. So, do you guys want to guess in the chat? What do you think this number is in standard form? Stick it in the chat. I want to see what you guys are thinking. And then we're going to move out of this. I'm just doing this 5 minutes, standard form. I want to give you super efficient, effective tips, and then we're going to move away. I'm not going to spend ages doing this. So, what are you guys saying? Let's get it. Let's get it. 4 point da 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 da. Okay, so just so everybody knows. Okay, this is really useful. I'm going to show you guys what everyone else is saying because I think this is just very useful to see where people are going wrong with this, where people are going right. So some people, okay, the first thing is it has to look like something times 10 to the something. So it has to look like that. So some people have just put a number in there. Well, it's not going to be the case. It has to be something times 10 to the something. And the first number has to be between 1 and 10. So most of you have put 4.73, which is correct. Some people have put 4.730. That doesn't I don't think you'd lose a mark for doing that, but some of you put 47.3. Now, 47.3 is too big because it's not between 1 and 10. So the first number here has to be between 0 and 10. So it's going to be 4.73. Now, again, some of you put a 0, some of you didn't. It's best to not write the 0 because you don't need it, but you wouldn't get marked down. Times 10 to the something. And I'm very glad that a bunch of you have put different things in it. We've got 2, we've got 3, and we've got 4. And this is exactly why I want to show you the calculator hack. Let's say even I'm sure some of you put 3 and thought 4, or put 4 and thought maybe it's 3 or 2, and you're not quite sure what the numbers are. This is where your calculator comes in handy. Okay, so if you think the answer is 4.73 times 10 to the 2, You would put it in, stick it in your calculator, because your calculator can't give you a number and give it in standard form. It's only occasionally when you get lucky, like in this question. Occasionally it does when the number's small, but when the number's big, it doesn't do that. But this is the hack. You just type it in. Look, 4.73 times 10 to the 2. Let's check. What is that? Oh no, that's 473. That's too small. So for those of you that thought it was times 10 to the 4, oh no, that's too big. Okay, so let's go back. I just go left, left, stick 3 in. Let me double check this one. Bang, 473. There you go. I know I'm going to get on to talking about trial and error, but this is kind of trial and error in a standard form context, which is like, I'm not quite sure what the answer is. You can use that calculator just to give you that confidence, just to double check you know what you're doing. Now look, now we've got 4 out of 4. And the only thing I've taught you today is that standard form has to look like something times 10 to the something. Okay. So if you didn't know that, you'll still get 3 out of 4. If you did know that, you get 4 out of 4 just by using your calculator. So the answer here is going to be, that's going to be to the power of 3. The reason is, and if you want to know how to do this on a non-calculated paper, the number up here tells you the number of times the decimal point has moved. So 4.73 times 10 to the 3 means you're moving the point 1, 2, 3 places. And you always put a little 0 in that arch, if you see what I mean. And do you see here? 4730. So that's the reason. Okay, there you go, 4 marks. Let's move on. Let's not spend ages talking about standard form, but that's it. I just know that people are a bit scared of standard form or they don't like it. I just want to ease that for you. So use your calculator and it all becomes very nice and manageable. Okay, that's it. Now, the next thing I want to show you is this trial and error. What was the question I wanted to show you? 6 and 13. Yeah, I just want to give you a couple of instances in this paper where trial and error was actually quite useful. So I don't think you guys are taught trial and error. I don't think you're taught properly. You might be told, well, try it maybe sometimes, but trial and error can really help you if you hate algebra. So option 1 is get really good at algebra. Option 2 is um, if you don't like algebra, well, okay, option 2 is learn trial and error as a backup and then try and get to grips with algebra later on. But if you hate algebra and you're allergic to it, I'll just show you there's a way of doing this without using it. So this is an example, this question here. I just want to quickly say before I even look at the question, you guys have to know, actually stick this in the chats. Without even reading the question, what is the first step of any question like this? Whenever you get a probability table like this, what's the thing that you're going to do? Like, what is the one thing? Yes, Yossi. Anyone else? Oh, sorry, very quickly. Brooke said, how can you make sure you get 2 marks, not one? You're talking about this one. You get 1 mark for writing this number here, and you get 1 mark for getting the answer right. So you should always be writing your working as you go through. So actually, can I just mention this because this is a really good question. So many people think, I don't need working, I don't need it. And so they'll just look at this and go, and they'll get this in their calculator and they'll guess 4.73 times 10 to the 4 because they're like, there's 4 numbers or something. And they'll just put this in the answer box. And if you do that, you get 0 marks, even though you knew that. And so you should have got an extra mark. So this is all to do with exam technique. Please, please, please write your working in the working box. And I know your teachers tell you to do it. And I know you ignore them because you think, yeah, come on, I don't really need to. But I've said this 100 times. I'm going to say it again. What is the highest grade that you can get on your GCSE higher paper if you get every single question wrong? Stick it in the chats. If you guys have been to my webinars before, you'll know this. What is the answer? What is the highest grade you can get if you get every single question wrong in the whole paper? And this is going to, if you haven't heard me say this, it's going to absolutely blow your mind. Yeah, Maddie's guessing 3. You'd think so, Maddie. The answer's a 7. Grade 7. You can get every single question wrong and still get a grade 7 just for showing your workings. So if you're like, why should I bother? That's why, because you can get a grade 7 just by writing things like that. It's crazy. It's crazy, but it's true. Okay, depending on the paper, but usually around a grade 7. So let's go back to this question. Yeah, some of you have got this. Wow, Maddie's done a mind blown emoji. Isn't that nuts? Isn't that nuts? Yeah. Everyone thinks the answer is it's all about the answer. Did I get it right? Did I get it wrong? And your teachers put the big ticks and crosses. That's not the point. The answer doesn't really matter that much. Like, okay, here, 4 mark question. Like here, the answer's only 1 out of 4. It doesn't really matter. Like the three before it are way more important. I would way rather get all the workings and then just screw up all my answers than get some of the answers right and then screw up the workings. That would be really bad. Okay. So back to here. A few people wrote this. Yeah, adds up to one. These numbers add up to one. Okay. Do you just have to know that, or you're just going to get zero on these questions? You see a probability thing. Actually, you could even write a card for this. Should we even write a card for this? Just say first step or method. Oh yeah, method. I don't know. First step of any probability table. Yeah, don't want to write this. First step of any probability table adds up to one. I guess, yeah, you would say that probably. First step of any probability table. And then just kind of go like, you know, e.g., color, probability, red, white, blue, whatever. You could just, I mean, you just want to make these cards really, really quick and then just like make up some numbers zero point 0.1, zero point 0.2. I don't know, just something like that. And on the back, just say like adds up to one. If you didn't know that, you got to know that. Bang. Takes 10 seconds to revise that card. Awesome. Move on. Take a picture of it if you need that. But this is where the trial and error comes in. So imagine you had a question like this, and you're like, okay, cool, cool. I know they all add up to one. And then they screw you with something like this. The probability of taking a green counter is zero point 0.2 more than the probability of taking a pink counter. Who feels fine with this? Who finds this annoying? Let me know in the chats. Don't worry that you're late, Poppy. Doesn't matter. Come on in. Not going to tell you off. This isn't school. Where have you been, Poppy? I want to know where you've been and why you're late. That's fine. Um, Annoying, says everyone. Annoying, 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 very annoying, very annoying. Yossi's put the answer. Amazing. Yossi, very nice. Well, let's see. Let's see. I'm not sure. Okay. A lot of people find this annoying and this will trip people up. So remember what I said before, which is, I mean, I was joking, Poppy, but I feel like I've really given it something. You've actually responded. I had to re-download Zoom. So Poppy, that's absolutely fine. You can take as long as you like to re-download Zoom. Yes, Ben, you've got this, right? All the numbers add up to one, but this is annoying. So all these add up to one, okay? So you could start adding them up. So 0.05 plus 0.15. Okay, and we get 0. Okay, that's 1/5, but we hit S to D, we get zero point 0.2. So we know that these are zero point 0.2. And then in here, they say the green one is zero point 0.2 more than the pink one. And I just know that a lot of people are like, oh, what? Oh, but, and then they just start guessing like zero point 0.2, zero point 0.4, something like that, right? A lot of people will just be like, well, something like that. But like this is where trial and error comes in. If you want to use trial and error here, just guess. So like this is a good example. You could just guess those two numbers. Those are two numbers. The green one's zero point 0.2 more than the pink, and now just double check. Do all these add up to one? So these two add up to zero point 0.2, and then if I plus zero point 0.4 and I plus zero point 0.2, no, it's not quite big enough. Okay, so now you might go a bit bigger. So I guessed zero point 0.4 and I guessed zero point 0.2, but my answer was too small because these only add up to zero point 0.8, but they should add up to 1. So now let's increase this by something like this. Let's try this, right? These would add up to um, this one's now zero point 0.2 bigger than that, right? I'm just guessing the next number up. Now let's check if these three numbers add up to 0.1, 0.2 plus 0.5 plus 0.3. Ooh, lovely. It works. Cool. Okay, great. So my answer is, sorry, I shouldn't have written those in the answer box. Uh, so my answer there is zero point 0.5 and 0.3. Do you see? I guessed something just to see what happens. It was wrong, but it didn't matter. Then I changed it and then I got it right. If this was too big now, you'd then go in between these two values, so 0.45 and 0.25, something like that. That would be a kind of a difficult, annoying one, but that definitely happens. So that's a great example of how trial and error can just be really useful. Because the other way to do this, and the way your teachers are probably telling you to do it, is the algebra approach. Let me just quickly show you the algebra approach. But like a lot of people hate this. So if you don't know what something is in a maths paper, one of the best things that you can do is call it X. So, but this is an advanced technique. I'm just going to move those out of the way for a sec. Let me just do this in a different color. You always want to call the smaller thing X, okay? So this thing is bigger than this thing, okay? So the pink one I'm going to call X, and I know that the green one is zero point 0.2 more than X. Stick it in the chat. What am I going to put then in this green box? Let me know. Some people are saying x plus 2. Some people are saying x plus zero point 0.2. This is interesting. Yeah, see, this is already why so many of you are just going to be like, yeah. So a bunch of people have said x plus 2, but it's zero point 0.2 more. So it's actually x plus zero point 0.2. But this is where people start making mistakes because they're not very familiar with algebra. Some people saying 2x as well. 2, yeah, a bunch of people saying 2x and some people saying x squared. Let me just talk about this very quickly because this is I think is a massive sticking point for a lot of people is dealing with x like algebra. It's just annoying. It's like, oh, what is x? I don't know. I think we're going to make a couple of cards on this. X squared is if they were like, this is this one squared. They would have to use the word squared. 2x is double. So if they said it's double, zero point 0.2 more is x plus zero point 0.2. So I think we should make a card on this, which is like, what is zero point 0.2 more than x? And on the back, x plus zero point 0.2. So what I'm doing is I'm trying to train you guys up to be good at algebra, but I'm just giving you guys this backup, which is if you can't be bothered on the day, just use some trial and error and it can help you. So you want to try to push yourself to do this sort of thing. This is like the equivalent of typing. If you guys are like learning how to type and you never use your little fingers because you're like, oh, I can't be bothered. Like you should try to use your little fingers to do that. But like if you can't be bothered one day or you're tired, you can just do that and bash it out. That's fine, okay? But when you can be bothered, try and use your little fingers because in the long run it'll mean you're better at typing. The same thing with playing the piano. You'll be better if you start to use your little fingers. It's exactly the same thing here. If you want to get better at maths, you should try and do this whenever you can. So whenever you don't know what something is in a maths question, you should call it X. That's a more advanced way of doing things. And ultimately, it just means that you can always get the answer right, but it is more difficult. Okay. So if you hate it, hate it, hate it, and you're just like, I just want to pass my GCSEs and I'm taking it in like a month's time, then fine. Just again, just do the easy approach, the trial and error. But like there's some questions that is going to be very difficult using trial and error. Anyway, does that analogy make sense? I hope so. This I think would be a very useful card. Also, for those of you not sure, like what is double X? If you want to get good at this algebra approach, you should make a couple of these cards. What is double X? And on the back, 2X. What is 3? Let's just do one more. What is 3 less than X? If you find these difficult, these 3 cards will just be really, really useful. X minus 3. And just quickly, for those of you that that already know these 3 things, I'm going to give you a harder one because I want to push everyone. I want to push you if you find these easy. This is hard, okay? What is 3 less? Hang on. I'm trying to do 2 at the same time. I'm just trying to think of a good example. What is okay. Do I want to do this? No, I'm just going to leave it there. Sorry, I'm going to leave it there. I'm going to leave it there. I'm going to leave it there. I think that's enough. I think that's enough. Um, okay, so let me show you how to do this using algebra now. You should say, well, all of these add up to 1. And so you need to form an equation, which is like, sorry, the first one plus the next one plus the next one plus the next one equals 1. I know that people find this difficult, but all I'm doing is putting a plus in between all of those things and then saying equals 1. That's it. Okay. And the reason why I teach you guys calculator hacks is that as soon as you have an equation, you can jump into your calculator. So you can do it on your calculator. If you have the CW, you just go menu and go to equation and then solver. If you have the EX, it's 991EX, then you can just do it like this. If you hate equations, when I give you this, like, yeah, I'm just going to do this quickly because I don't want, that's not the point of this lesson. And again, if you've got access to all my calculator hacks, you can just go watch all this stuff. Shift solve equals bang, zero point 0.3. So you get the answer 0.3. Bang. I mean, it's just crazy. And that is the smaller one, 0.3. So that's what we found earlier. I'm not going to show you how to solve this equation. Normally, you just collect like terms, move stuff to the other side, divide by stuff, whatever. I'm not doing solving equations now, but I'm just showing you this is how to do it using algebra. That's how to do it using trial and error. So all I want you all to sort of use trial and error whenever you can, whenever you're stuck, but start to try and use this kind of stuff. Okay, I'm going to show you another question where this came in handy. Here. Okay, this is a really horrible question. Okay, but I want to break it down for you using, again, there's two approaches, and this is on the same paper. This is exactly the same thing that we just did in the previous one, but there's an algebra approach, which is difficult, and then there is a trial and error approach. So have a look at this. Now, do you guys know my first big tip for how to do any question like this on coordinates? I've got a really useful overarching technique. Do you guys want to write it in the chat if you know what I'm talking about? If you come to my webinars before, you should. I've said this stuff before. No, no one said anything. No one's got this. Okay, let me tell you. It's not to add the points, Sienna. Nice guess. It's not to add the points though, but that's a nice guess. That's a nice guess. Um, it's even bigger than that. It's overarching. Lily is saying vectors. It's actually more overarching. Sabrina doesn't have a clue. Let me tell you. Separate x and y. So this is your big technique for how to do this. Just separate the x and the y. So here, there's a point down here, and there's a point up there, and they want this point. It's impossible to do this question without separating x and y. Because people are like 3,4 to 1120. How do you get from 3,4 to 1120? That's too difficult. So you want to just be like, right, imagine that only the x exists, which means the first number. I've got 3 and I've got 2 and I've got 11. How do I get from 3 to 11? Do you see how much simpler this is already? I add 8. Okay? Or you could use your calculator if you want, but you've got so that's saying from here to here is like plus 8. Okay, now how do I get there? I'm just going to quickly summarize this question. So this is like there's all these are identical rectangles. Okay, so all the rectangles have like a big bit and then there's like a small bit. So the big bit is like this length there, big, that one's big, and that little one is small, if you see what I mean, this little one there. We could call this small. So we got a big one and then a big one. So if I took this number 3 and I added a big one to it, I'd get to there. And if I added another big one, I'd get to there. But now I'm too far because I want to get back to 11. So then I would minus off a small one. So I basically got like a big one plus a big one minus a small one is equal to 8. Do you guys see that? That's the gap is 8 between those two x values. Now this is difficult, so I'm not saying everyone's going to find this easy, but it's like if I went like a big one, and then came back a small one, that whole thing is 8. Let's try and do the same thing with the y. Started with 4, I ended with 20. So that's a gap of 16. Okay, so this thing is like a gap of 16. And how's it made up? Well, I got a small one. From here, I go up like a small, then a big, and then like a big. Do you guys see that? So it's like a big there, then there's a big there, then there's like a small. And so I've got kind of like big plus small is equal to 16. Does that make sense? Just visualizing that? Just let me know in the chats. Does that sort of thing like make sense roughly? I know this is tough. Okay, I'm not saying this is an easy question. Martha's saying no. So Martha, essentially, what's happened is they've given you a coordinate down there and up there, and they haven't really told you anything else. So I think this is just a really nasty question. Sophia says, "Yeah, okay, okay." So Sophia and Sabrina, okay. Now listen, I am pushing you. This is weird. If I tell you the real way to do this, though, you're going to be even more lost. So let me just say that this is a difficult question. They're just saying, here's a point down here, here's a point up there. Let me get rid of all this stuff because there's too many bits. They're saying point there and a point there, and they've given you the coordinates. Okay. But they haven't told you anything else, and they're like, find what C is. So this is a crazy difficult question. But the way to do it is to be like, um, we know like from the height from this up to here. It's like, how do I get from there up to there? Well, I go up, so I go like one width of that rectangle, and then if I take this line and then move it over there, bang. Do you see I've got now like a length? So that let's call that big. And then if I go up again there, and again, if I slide that over to there. Do you see that now I've got the full height between 20 is the y coordinate of that point and 4 is the y coordinate of that point. So that means that's 4, that's 20. And it's like, well, how do I get from there to there? There's like a small bit and then a big bit and then a big bit. Small, big, big. And they all go from 4 to 20, which means in total, small plus big has to be equal to 16. I hope that's okay. Okay, great, great. Sienna and Sophia, you say that. That's making more sense. Okay, great. Um, and I know this is hard, okay? But just this is where the trial and error can come in. So they're asking us to go find something, right? But it's like we've got to work out what's the small bit, what's the big bit. This is where trial and error can come in. Just guess, just completely guess. So, what's an idea of like a small and a big? Should we go like one, one and like five, like, or let's guess this is like five. I'm just plucking this out of the air. Just let's just guess that big one's five. Well, that means that one's five. So that's 10. But the whole thing has to be 16. So that would have to be six. Well, that doesn't make sense because that's smaller than the other one. Okay, so five doesn't work. Let's try a really big one, like 10. 10, and that's already 20. That's bigger than 16. Okay, so it's somewhere between 5 and 10. Like that's the answer. Let's guess 8. Should we guess 8? 8 and 8 is 16. That leaves nothing for that. Let's try 6 and 6. Oh no, let's try 7 first. 7, 7 is 14, and then 2 would get to 16. Does that make sense? 7, 7, and 2. So let's guess. Let's guess 7 and 7 and 2. So that means this is 7, and this is 7, and this is 2. So that would be like 7 onto 4, that's 11. Then another 7 onto 11, that's 18. And then back 2 would be 16. Ah, no. So we got that wrong. So it's not 7. Do you see what I mean? The original guess was 7. So it wasn't 5, it wasn't 10, and it's 6, 7, 8, or 9. It's one of these. Oh, sorry, we said it wasn't 9 and it wasn't 8 because if you guess 8 and 8, that's 16, and there's nothing left for that one. Do you see? Because this whole gap has to be 16. So you're just chipping away. And it wasn't 7. So it's got to be 6. Now, I actually knew already the answer was 6. So I've deliberately gone a long way around this to show you how long it can take. But if you had just guessed 6 to begin with, you'll end up with the correct answer. So let me now show you what happens if you guess 6. I'll do this in pink. If this is 6 and this is 6, that's 12. But in total, we want that gap to be 16. So this would be 4 down there. Okay, now we try this way. So not 7, we guess 6, 6, and this is 4. So if you took this x coordinate of 3, and you want to go up and get 11 eventually, you go up by 6, so that's 9, and then up by another 6, so that's 15, and then back 4, bang, you get to 11. Okay, so it works. So 6, 6, and 4 work. So the length of all these rectangles is 6, and the width is 4. And now the question says, find the coordinates of C. Let me just show you quickly. So it's the same. What are we doing? We're going across 6 and up 4. So from 3, 4, we're going across 6 and then up 4. So across 6 means adding 6 onto the x one, so that it goes to 9. And then up four means adding four onto that one, so that goes to eight. So there's your final answer. Now, I know that's taken a while because I've deliberately shown you the slowest possible way to get there, which is guessing five, guessing 10, they were both wrong, and trying every single number in between and ending up with six. But as I said, this can be way quicker because if you happen to guess six, that would be great. I know that's not easy, okay? Bobby said you got to go. That's fine. You go whenever you want, and you can watch back whenever you want. You guys will get the replays. Is there a topic video for this to watch? Yes, Sienna. So this is what topic is this? Coordinates. So yeah, if you go and look at my coordinates videos, the big thing I try and push you guys to do is to separate X and Y. This is just happens to be a very nasty question, but do you know what the mark scheme said? And do you know what your teachers will tell you to do? They'll teach you to do this. If like, do you guys remember what I said in the previous question? If you don't know what something is in a maths question, what should we call it? Stick it in the chats. What should we call it if we don't know? Yes, guys, X. So and we always call the smallest thing X. So the width of this rectangle we could call X. Okay. Now, what are we going to call the length? We don't, if they said it's double, then we call it 2x, but we don't know. Yes, Tia, call it y. Yes, Martha, exactly. If there's two things you don't know, you call it y. So this is how you're supposed to do this question, is you say, do you see here I said big plus big minus small equals 8? What you're supposed to do is to convert that into algebra and say two bigs minus a small. So a big is y. So we call that 2y minus x is equal to 8. And this is two bigs, so that's 2y plus a small is equal to 16. Bang, simultaneous equations. Oh, right? And then you've got to do this whole thing where you like add them together and then you get 4y. They cancel each other out. 4y equals 24. So y equals 24 over 4, which is 6. So the length is 6. And then you've got to plug this back into this equation to go find what x is. You're going to get 6, you're going to get 4, bang. You're going to get the same thing that we found over here. But the algebra is quite nasty. And I know a lot of people hate it. You've got to decide to call it x, decide to call it y, set up two equations that are simultaneous, then solve the simultaneous equations and substitute one of the values back in to get the other value. Ah, nightmare. Okay, if you follow me, you'll know that you can do simultaneous equations on your calculator. Ha 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 ha. So you can do this on your calculator, okay? Ba, 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 ba. You just literally plug this in here. 2 minus 1, 8. 2, 1, 16. I'm just doing this quickly, but bang, 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 bang. You can do it here. You get x is 6, you get y is 4. Oh, sorry. Sorry. I put X first, then Y. I should put them the other way around. But either way, you see, you can get the answer on your calculator by doing it that way. But do you see how long this is? Now, I don't know what you guys prefer. Do you guys prefer this method? Do you guys prefer trial and error, or do you prefer this? Stick a 1 in the chat if you prefer the trial and error. Stick a 2 in the chat if you prefer. And this is not a trick question. I mean, either if you prefer the algebra. Will, you said this is crazy. What are you talking about, Will? What's crazy when you said this is crazy? Do you mean, uh, yeah, let me know. This is interesting. So you guys are split, and actually, most of you are saying two. This is good. Okay, if you're saying two here, yeah, okay. Martha's saying you hate algebra. There's too much going on in the first method to keep track of. Yeah, fair. Okay, so this depends on how allergic you are to algebra. So what I'm just trying to do is it's really useful that I'll teach you trial and error, and some people will be like, okay, not for me. I'd actually rather do the mathsy stuff. Now, this is the better way to do it. So I do want to encourage you guys to try and do this wherever you can. So this is your rule. When you don't know what something is in a maths question, call it X, okay? And use the stuff we were trying before and see how far you get. And if you get all the way to the answer, amazing. If you get stuck and you're not sure what to do and you run out of steam, I'd say come back and try trial and error. This just happened to be one of the nastiest trial and errors out there. Okay, so I know there's too much to keep track of there. That is nasty, but you can just start guessing stuff and just use your intuition to be like, wait, my guess was a bit small, so I'm going to make it a bit bigger. Some of you said you preferred this approach. In that case, great, stick with that. But like, so I do want you guys to know that even if you prefer trial and error, try and learn the algebra. I'm just giving this to you to say, if you're stuck in an exam, look, this is a 5-mark question, okay? And so many people are getting 0 on this because they can't set up equations and simultaneous equations. So I'm just showing you, if you just start guessing some stuff, occasionally it'll work, and it's worth trying for a 5 mark question. I mean, it's a crazy amount of marks. That's half a grade boundary. That's quarter of the way to passing your GCSEs in one question. Okay, so this is very important stuff. Okay, so I'm live streaming some of this, so I'm going to end it there for those watching free. Let me just stop that, and then let me hop back into the yeah, for those of you watching free, thanks. See you later. Bye. But I'm just going to go in with the premium lot to answer their questions and everything.